Hello, everybody. You ever wonder why, if you have a piece of paper currency, it's dirty, generally? So, do you know why it's that way? Well, because believe it or not, when you pay $2 at the store for a Twinkie, that $2 doesn't stop there. It goes from your hand to the grocer's, from the grocer to his people to divvy it all up for the people that contributed to the Twinkie, the wheat growers, the chemical plants that produced all the preservatives. I've heard that those things have a shelf life of about 300 years. So anyway, everybody gets their part of it. And of course, the chemical plant gets their $2 worth or their share of it, and then they buy other things to go into Twinkies or their other chemical products, and so it goes on and on. And somewhere out there, one of the handlers or some of the handlers don't wash their hands and it gets, dirty. But fortunately, this is not to be a recording on either currency freshness or digital cleanliness. This is a little recording about the multiplier. And the multiplier exists because of that fact that money changes hands. Let's talk about multiplier a little bit here. And what we do for that, of course, the multiplier affects aggregate demand, okay? I'll put aggregate demand in black. Now, you know what they say, black is the new orange. So aggregate demand looks like that, of course. And the components of aggregate demand, like we've said numerous times before, GDP, and aggregate demand is a relationship between the price level and real GDP. It equals consumption plus net investment plus government purchases plus net exports, okay? So the multiplier comes into effect when we change one or more of these components. What happens when we change one or more of those components? Again, if we focus on the components, we're focusing on something different than the labels of the axes here of our diagram. We're not talking about the relationship just between price levels and GDP. We're talking about an actual external change to one of these components of GDP. So let's see what happens here. Let's say government increases spending by 2%. I won't get into the current administration and the chance of that. But let's say that they, like 2% more is injected into the economy, okay? Well, because it is a component that is changing and it's more, so that would mean that at every average price level, more GDP is being produced, okay? So you would think with a 2% increase, you know that aggregate demand is going to move out, but how far out do you think it goes? Well, let's say this would be 2% here. So would it move just out this far? No. It would move farther than that because money circulates and money produces value of more than just one transaction. So it would move out by the initial change, the increase in GDP, would equal the initial change in G, or one of the components, times the multiplier, okay? And at this point, we know the multiplier, the definition the book gives you, sort of an introductory definition, is after the fact that the multiplier equals the final or resulting change in GDP, real of course, divided by the initial change in aggregate demand component. So then, a 2% increase thrown into the economy will produce more than a 2% increase in aggregate demand. Or say, because aggregate demand is the relationship between the price level and real GDP, the aggregate demand curve at every price level, more GDP will be consumed. Okay, so the curve might move out that much. Okay, so what it does move out, it will move out the increase or the change in aggregate demand will eventually equal the change in the GDP component. Oh, excuse me. It will equal the change in real GDP, final, the resulting change in real GDP, divided by the initial change in one of the GDP components, or more. And I'll put component with a little s in parentheses because it could be one more. Okay? Now, we'll be deriving this later on algebraically so that we can tell what the effect will likely be. But for right now, we're sort of defining it after the fact. So, essentially, the change, the resulting total change in GDP, real GDP, equals the initial change in component, GDP component, possible components, times the multiplier. Okay? And this works in reverse. If there is a drop in one of the components, say if the administration cuts social spending by 2%, the resulting drop in GDP and aggregate demand will be more than 2%. It will be the multiplier times the initial change. So this shows how, remember that we said that in the beginning of our course, that every policy has a positive effect for some, negative effect for others. And this is just one of the reasons why that's true and why policies should be very much studied and considered soberly. Thank you very much, and we'll go on to aggregate supply.